I'm going to break this chapter up into a couple of different subsections. The first one, I'm going to review a little bit about redox, and then I'm going to talk about the units, but I'm also going to show you some examples of redox reactions, and then talk about how you can calculate the electrochemical potential or voltage, as maybe you're familiar with the term, for an electrochemical cell. So let's start with a little bit of review. In Chem 1A, you learned about oxidation and reduction. You may have learned the saying that Leo says Gur, and in the saying Leo says Gur, it means lose electrons is oxidation, gain electrons is reduction. So there's a reductant and an oxidant. An oxidant is the oxidizing agent, and a reductant is known as the reducing agent. And you'll see these different terms. I think the book primarily uses reducing agent and oxidizing agent, but there's all kinds of terms for these kinds of things, and I just wanted you to be familiar with those. So let's take a look at this reaction, and we'll talk a little bit about balancing redox reactions as well, sort of formally. But I have zinc ion in a solution with silver metal, and I get zinc solid and silver ions. Now the question is this a balanced reaction? And at first glance it seems like it might be, because there's one zinc and one zinc and one silver and one silver, so we have a mass balance situation. But in fact what's not right is that there isn't the same amount of charge on each side. And for a reaction to be truly balanced, you have to have both mass and charge balance going on in the reaction. Now, it's a pretty simple matter to balance this one. What you can do is you can just put a 2 in front of each one of these. And then that reaction becomes balanced because I have a total of +2 on the right and -2 on the left. But what I wanted to show you is that this is actually a redox reaction. And you have a redox reaction when the oxidation number changes. So I have a zinc 2+ here, and this is zinc 0. So the oxidation number, which is the charge on these ions, is going from +2 to 0. Then we know that this is being reduced, and it must be gaining electrons in order for the charge to go from positive to neutral. And then silver is going from silver to +1. And since it's going up in charge, it means it must be losing electrons. And so in effect, what you can see in this reaction is the zinc is losing 2 electrons. So there must be 2 silver atoms. Zinc is gaining electrons. So there must be 2 silver atoms to give the electrons to the zinc. Now another way to do this is to split this reaction into 2 pieces, and to split it into what's being oxidized and what's being reduced. So to do that, what you do is you write what's called half reactions. So I can say zinc 2+ goes to make zinc, and that's one half reaction. And my other half reaction is silver goes to make silver plus, and this is my other half reaction. I'll leave the states off, but you can get them from up here if you really want them. And this is what you do. You say, okay, in order for zinc to be 2+ and then go to 0, I must be adding 2 electrons to this side. And that half reaction is said to be balanced because I have the correct number of charges on the left and on the right. And I also have mass balance. And then if I look at the silver, well, I have to say to myself, in order for silver to go to silver plus, I have to lose an electron like this, and that this half reaction is balanced. But in any redox reaction, these 2 half reactions need to balance in terms of the numbers of electrons. So if I look at the silver, that gives me 1 electron and the zinc gives me 2, I know I need to multiply the second reaction by 2, and then I can add the result together, and I can cancel the electrons before I add it, like this, and then get Zn 2+ plus 2Ag goes to 2Ag plus Zn solid. Now, This reaction that's at the top is known as the reduction reaction, because the oxidation numbers are going down. But another way to look at it is to think it's gaining electrons. So if you're gaining, right, gain electrons, your reduction. Here we're looking at losing electrons, and so this is the oxidation reaction. And this is true for any redox reaction, that you have an oxidation half reaction and a reduction half reaction going on. And also, because the silver is providing the electrons, this is known as the reducing agent. So the silver provides the electron, is a reducing agent. And the zinc that accepts the electron is the oxidizing agent. Like that. Okay, so I know it's a little cramped in there. I just wanted to get it all in one place. So what I'm going to do next is I'm going to do a little bit more of a formal review, balancing redox reactions using the half reaction method, which you're probably taught in your Chem 1A class. But this is a good chance to review it before we sort of get deeply into the electrochemistry chapter.